Hello friends, welcome to our channel. Today I shall discuss our next problem on radius of curvature. So the given curve is of the form x is equal to a into log of sec t plus tan t and y is equal to a into sec t. So for two different axes they have given the equation. We need to solve it separately. First we need to solve x and then y. So first we shall consider x is equal to a into log sec t plus tan t. So this is the given equation. So consider it as equation 1. So first step is we need to differentiate the given equation with respect to theta. So that is differentiating with respect to t. So differentiating the given equation with respect to t, we have dx upon dt. Dx upon dt is equal to then a divided a into. So the differentiation of log x is nothing but 1 by x. So it will be, so log of sec t plus tan t will be 1 divided by log of sec t plus tan t. That is a divided by log of sec t plus tan t. So we have differentiated a, then differentiation of log is 1 by x. That is 1 divided by log of sec t plus tan t is equal to. So that is a divided by. It is written as sec t plus tan t into. So then differentiation of sec t. So differentiation of sec t is nothing but it will be sec t into tan t plus differentiation of tan t is nothing but sec square t. That is dx upon dt is equal to a into sec t into tan t plus sec square t divided by sec t plus tan t. So by observing the numerator we can see that sec t and sec t we can take common. So that will be a into. So we can write it as a into sec t is common. So it will be sec t into bracket remaining will be sec t plus tan t whole divided by sec t plus tan t. So here we can cancel sec t plus tan t and sec t plus tan t. So remaining is a into sec t. So therefore we found that dx upon dt is equal to a into sec t. So we have obtained a differentiation for one equation, that is x is equal to a into log of sec t plus tan t. And the next step is we need to find the differentiation for the y. That is y is given by a into sec t. So now we need to find the differentiation of y with respect to theta, with respect to t. So we need to differentiate with respect to t. So consider it as equation 2. So now differentiating equation 2 with respect to t. So it will be dy upon dt is equal to, so a into differentiation of sec t will be sec t into tan t. So therefore we got that y1. So therefore we can write it as y1 can be written as dy upon dx, which is nothing but dy upon dx is nothing but it will be dy upon dt divided by dx upon dt. That is dy upon dx we can express it in terms of dt as dy by dt divided by dx upon dt. So it is dy upon dt. So this is dy upon dt. So dy upon dt is nothing but a into sec t into tan t divided by dx upon dt is nothing but a into sec t. So here again we can cancel a into sec t and a into sec t, so remaining is tan t. So this is nothing but y1. So thus we obtained that y1 is equal to tan t. In order to apply the formula of radius of curvature, we need to obtain y1 and y2. So y1 and y1 square, that is first differentiation and second differentiation. That is first order differentiation, we can write it as y1. Similarly, we need to obtain the second order derivation. Second order derivation can be obtained by differentiating the y1 term again. So we need to differentiate the y1 term again. So differentiation of y1 will be y2 is equal to differentiation of tan t is sec square t. So sec square t into tan t. So differentiation of tan t is sec square t. So we need to differentiate it with respect to t. So it will be dt upon dx. So you can write it as y2 is equal to sec square t dt upon dx. So dt upon dx we can write it as divided by a. So this therefore y2 will be equal to sec square t divided by a. That is y2 is equal to sec square t divided by a. The given equation is of the form we have dx upon dt is equal to a into sec t. Here we need to obtain dt by dx. So that is sec square t into dt upon dx. So sec square t dt upon dx. So reciprocal of this will be 1 divided by. So reciprocal, that is dt upon dx, is nothing but 1 divided by a into sec t. So here we need to write the dt by dx. So in order to write dt by dx, it will be sec square t into dt upon dx. That is y2 is equal to sec square t into, so dt upon dx is nothing but 1 divided by a into sec t. So 1 sec and 1 sec will cancel. So remaining will be sec t divided by a. So therefore we also obtain the y2. y2 is nothing but sec t divided by a. So we have obtained y1 and y2. y1 is nothing but tan t and y2 is nothing but sec t divided by a. So we have obtained y1 and y2. Now we need to apply the radius of curvature formula. So the radius of curvature is given by rho is equal to 1 plus y1 square raised to 3 by 2 divided by y2. So now we shall apply the, now we need to substitute y1 and y2 in this equation. So it will be 1 plus, y1 is nothing but tan t. So it will be tan t y1 square. So it will be square raised to 3 divided by 2 divided by y2 is nothing but sec into t divided by a. So therefore we can write it as, so sec t by a, it will go to numerator, it will be a into 1 plus tan square t divided by sec into t raised to 3 by 2 as it is. So therefore we can write it as a into 1 plus tan square t is nothing but sec square t. So sec square t raised to 3 by 2 of any trigonometric function, it remains the same. So it will be a into sec square t divided by sec t. So here sec get cancelled and the remaining will be rho is equal to a into sec t. So this is the required radius of curvature equation. So that therefore we have obtained the radius of curvature to be rho is equal to a into sec t. Thank you friends. Subscribe our channel for more updates.